So far, everything we've used has been built into Python, but most of the time when I use Python, I'm using external libraries. And so there's two steps to using an external library. You have to install it on your system so that Python can access it. And I'm going to assume in this video that you already have NumPy installed. So I'll provide a link or instructions for how to install it, whether you're on a Mac or PC, together with this video. But because it's a little different depending on your system, then I'm not going to include how you install it in this video. So installing NumPy or whatever the library is step one. Step two is import it, and here is how you import it. And theoretically, you could just stop here, but the convention, and we should always follow this convention, is to import it using the abbreviation NP for NumPy. So that means that instead of having to type out the full name NumPy, you can just type this abbreviation NP when you want to use this library. So there I've imported it. If you get an error here, then that means you don't have it installed and you should install it first, and then you'll have to restart the notebook potentially. No, maybe that's not true. Maybe you don't have to restart it. Okay, anyway, you will find that NumPy is very similar to MATLAB. So for example, you can do np.zeros, and this works very similarly to how the zeros function works in MATLAB. So for example, I can give this as an input, the tuple 3, 5. And this makes 3 by 5. I sort of think of it as a matrix, but technically this is what's called a NumPy array. So let me save this with the name capital A. And let's check what's the type of that. Okay, this is ND array, and that stands for n-dimensional array. And in this particular case, you should think of it as two dimensions. There's the rows dimension, okay, which has length 3, and the columns dimension, which has length 5. And if you check a.shape, that tells us, so that returns a tuple, and that tells us 3 rows by 5 columns. So for making this alternating list, we want to have, it's just going to be a one-dimensional array, and we want it to have length n. So let's call this alt3. Input is going to be n, and let's say capital A equals np.zeros n, and then let's return a. And let's see how that looks. Oh, and I need to call the function. So alt3 of, let's try 7. So this is a length 7 NumPy array. And there's one little issue here. Notice these decimal points. Like, let's access one of these elements. So the way we can access it is with indexing, just like with a list or just like with a tuple. And let's check what is the type of this thing. So this is what's called, so this is inside of NumPy, this is what's called a float 64. So the 64 says how much precision this has, and float is same as float in Python, saying this is a real number, it doesn't have to be an integer. So I would rather these be integers. So let me save this with the name capital A. And I can check what is the data type overall. And this says the data type is float 64. So same thing we got here. And so let's change the definition a little bit. And if I check for help np.zeros, okay, and make sure you don't put any parentheses after this, then you can see that one of the parameters this is allowed to take is dtype, which says what data type should you use? Like, should it be an 8-bit integer? Should it be a 64-bit float? And so on. So let's use that down here. So let's say dtype equals np.int64, okay, for a 64-bit integer. And now let's check alt3 of 8. So now notice those decimal points went away. That's just going to make it a little more similar to what we were doing in the previous video, where we were getting integers here. Okay, great. And so if I look at this A, okay, it's the same as the previous one. I haven't redefined it here yet. Maybe I'll do that. And so if I want to get a NumPy array of all threes, this works the same as it works in MATLAB. You can just do +3. And here we get all threes. If you try to do that with a list, like you say my list equals 0, 0, 0, and then you do my list +3, that doesn't work. So if you want to do this kind of element-wise addition, needs to be with something that supports it, like a NumPy array. So let's come back here, and let's say, let's just add 3 to this. So now we can do alt3 of 5, and I get this length 5 list of all threes. Okay, good. Now the only thing that's left, so let's again call this A. Now the only thing that's left is I want the even indexed terms to be, or sorry, the odd indexed terms I want to be 8. And if you remember before how we did this, was we, in the very beginning, we said for I in range from 1 go up to, but not including n, go up by 2. So this is like 1, 3, 5, and so on. Set those equal to 8. Well, there's a nice abbreviation for doing that. I can say A1. Okay, let's just leave that blank. So this is using slicing here and go up by 2. So what is this doing? This is giving me this 3 and this 3. And this works for NumPy arrays. This does not work for lists. I can assign this. So I can say, I want these to be equal to 8. And I definitely can't write n here because n is not defined. So I just leave it blank that says go as far as possible. Okay, now if I check A, it has changed so that the odd indexed terms are now equal to 8. Okay, so we can say A1, and if you want, you can do n here, or you can just leave it blank. It doesn't matter. So you can either have an n in the middle or leave it blank. Then we can set those equal to 8. Okay, and let's check that this is working. And again, we should be sure to check it for both an odd input and for an even input. Yep, looks like that's working. Maybe I'll just say one more thing, which is that this kind of assignment, this does not work for a list. So let me show you what I mean. My list equals 3, 1, 4, 1, 5, 9. And let's say my list blank blank 2. So this is getting me this 3, this 4, and this 5. And if I try to set, like let's say set those to all equal -17, here I get this error, and it says must assign iterable to extended slice. So I need something where it can like get the initial thing and replace 3 with that, get the next thing, replace 4 by that, and so on. So this kind of abbreviation, it's allowed with NumPy, it's not allowed with lists. So let's call this my array, and let's convert my list into a NumPy array. So remember, like if you want to convert it into a tuple, you do tuple my list. If you want to convert it into a NumPy array, you do np.array. Okay, I would have expected it to be nd array, but this is how you do it, np.array. Okay, and then let's try this exact same code here, but with my array. And that one, it did not give me a type error or any kind of error. And let's check. So here you can see that those even indexed terms, they've gotten replaced by -17s. So this kind of syntax, it works for arrays, for NumPy arrays. It does not work for lists. If you want it to work for a list, you can do something like my list : 2 equals -17, -17, -17. And then if I check, that works. But why is this so much worse? Well, it's definitely worse because I had to know to put in 3 of them. If I had done my list equals this, then I get an error because it says does not have enough elements to put here, to put into those 3 slots. If I had -17, -17, then again, here it's too many. So definitely if you want to do this sort of assignment, then it's much more convenient to do it using NumPy.